Hello. So here I'm going to talk about the sum and difference formulas or the addition formulas. And so say we have a unit circle. Say we have a unit circle where r is equal to 1. Our radius is 1 for the unit circle. So the radius is 1. It can be any triangle. So if we have this triangle here, angle T goes up in this direction, angle S goes all the way over. Therefore, the inner angle is going to be the difference of the two angles, S minus T. So in this configuration, point P is at cosine T sine T. Point Q is at cosine S sine S. Okay, if we take the same triangle on the unit circle and we rotate this around, we get this configuration where P is at 1 comma 0. We still have the central angle of S minus T. And this point over here is cosine of S minus T and sine of S minus T, because again, our radius is 1. Okay. So since it's the same triangle being rotated about the unit circle, this length PQ is the same in both triangles. Okay. What is the length PQ? Well, your length is going to be the difference of your x values plus, the difference of your x values squared plus the difference of your y values squared, all of that being square rooted. Let me put that in two words here. So the distance is equal to so there's your distance formula. Difference of the x's squared plus the difference of your y's squared, and all of that being square rooted. So I'm going to use this to find this distance, and since it is the same as this distance, I'm going to set them equal to each other and see what we come up with. So that's the idea in mind. So we have PQ is equal to the square root of the difference in the x values. So we have cosine S minus cosine T, all of this being squared, plus the difference of your y values, sine S, sine T. And all of this is being squared, and with the square root of all of that. Okay, so this tells us that line segment PQ is equal to, so cosine S minus cosine T, all of this squared. This is like A minus B squared. So A minus B squared, we're going to square the first term, square the second term, and it's 2 times their product. So we have cosine squared S plus cosine squared T, and then minus 2 times their product. And then we're adding this to this being squared. Let me write a little bit smaller here. So we have the square of the first term plus the square of the second term, and then plus 2 times their product. And then plus square the first term, square the second term, plus 2 times their product. And all of this is being square rooted. Okay. Now, notice we have cosine squared of an angle of S plus sine squared of an S, that gives you 1. And we have cosine squared T plus sine squared t, that equals 1. Okay, so this is the same thing as PQ is equal to, so the square root. We have 1 plus 1, which is 2. And this, no, this cannot be simplified. Okay. Okay. So length PQ of the first triangle is the square root of 2 minus 2 cosine S cosine T minus 2 sine S sine T. That's this length here. Then we can go for this length here. Okay. It's still PQ. The length is the same. And so we have PQ is also equal to the square root of so it's the difference of your x values squared plus the difference in your y values all of that being square rooted. Okay, so we have cosine of, we have the first x value and then minus the second x value, all of that being squared, and then plus the first sine value minus the second sine value, all of that being squared, and the square root of all of that. Okay, let's clean this up a little. We have PQ is equal to, okay, square the first term. We have cosine squared of S minus T, and then square the second term, and then we're going to add 2 times their product. And then do the same thing over here. Plus, we have sine squared S minus T and then the 0 gets absorbed. This is the same thing as just sine squared S minus T because of the 0. Okay, and it all needs to be square rooted. Now, what we have is cosine squared of an unknown angle plus sine squared of that exact same angle. Therefore, this is 1. 1 plus 1 is 2. So this is PQ is equal to the square root of 2 minus 2 cosine S minus T. Okay, so what we have is this is one definition of PQ, and this is another definition of PQ. Since it's the same line segment, we can set these two equal to each other. Okay. So we have the square root of 2 minus 2 cosine of S minus T is equal to the square root of 2 minus 2 cosine S cosine T minus 2 sine S sine T, and all of this is being square rooted. Okay. If you square both sides, the radical goes away. Okay. Now we can subtract 2 from both sides. So if we subtract 2, we subtract 2, we get this. We just subtracted 2 from both sides. And then I can multiply both sides by a negative 1/2. And what this gives me is cosine of s minus t is equal to, so negative 1/2 times negative 2 is positive 1. So we have cosine of the first angle times cosine of the second angle. And then a negative times negative is a positive. So we have plus sine of the first angle times sine of the second angle. This is your sum and difference formulas. This one is a difference one. Okay. And then they do similar steps to come up with the other proofs, but I've summed them up here. And I prefer alphas and betas. I do not like writing s's and t's because my s's look like 5s and my t's look like plus signs. So without loss of generality, we can do the same thing, and we get sine of alpha plus beta is equal to sine alpha times cosine beta plus cosine alpha times sine beta. We also have sine alpha minus beta is sine alpha times cosine beta minus cosine of the first times sine of the second, if you want to see it that way. Cosine alpha plus beta, cosine of the first, cosine of the second, minus sine of the first times sine of the second. Cosine of alpha minus beta, cosine alpha, cosine of the first times cosine of the second, plus, with cosine, they're alternating signs. Sine alpha times sine beta. We get tangent alpha plus beta is tangent alpha plus tangent beta divided by 1 minus the product. And then if we are subtracting tangent alpha minus beta, you have tangent alpha minus tangent beta, all divided by 1 plus tangent alpha tangent beta. So I believe the calculator was invented in 1973. Not sure when computers were invented. I want to say in the 40s. But mathematicians have known about trigonometry and the trig tables for hundreds of years. And this is how they would fill out the tables. They would find the 30, 60, 90 triangle, the 45, 45, 90 triangle, and then they would apply sum and difference formulas to come up with all of the other values. Extremely laborious process before computers. But now with computers and calculators, it's a lot quicker to do it. But I'll show you how to do these by hand. Okay. So that's just a brief video on the proof of the sum and difference formulas or the addition formulas. Thank you very much. Please go to tutoring.